All right, this lesson is all about radicals and simplifying radicals. So again, radicals is kind of a fancy word for square root. So in order to understand square roots, we have to understand exponents and squares. So any exponent with a power of 2 is what we kind of say it's called a number squared. So this would be 3 squared, which means 3 times 3. You multiply that number however many times the exponent is. So if it was 3 to the third, you would do 3 times 3 times 3. But we just have 3 squared, so we do 3 times 3, which is going to give us an answer of 9. So very similar is square roots, except square roots are kind of like the opposite of squares. So I want to work backwards, and I want to say, the square root of 9. What number multiplied by itself can give me 9? Well, that's 3. And when you have square roots, there's actually a couple answers. Because, again, 3 times 3, a positive times a positive is a positive. But also, a negative times a negative equals a positive. So we have 2 answers for that one. Now, sometimes when we're doing problems, a negative number might not make sense, so we may not include it. Here's an example again. Squares and square roots are related to each other. And when you take the square root of a squared number, you cancel it out. It basically cancels out. So all you're left with is 3. And again, that was the answer we got over here. So let's look at a number, the square root of 96. So if I'm looking at the square root of 96, I want to try to find the largest perfect square I can find. So our perfect square numbers, and again, these are numbers that you're going to want to kind of start memorizing and kind of learning. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. And 8 squared is 64. ... Okay? So I see that, so I know that there are these perfect squares. Now I want to break up 96 into all its the different numbers that multiply to get 96. So I could say 1 times 96 or 2 times 48, okay? But the largest perfect square, if we highlight our perfect squares, I see a 4. I also see a 16, okay? So again, 16 is our largest perfect square. So we're going to rewrite the square root of 96 as square root of 16 multiplied by 6. Now, when you multiply numbers, okay, well, we got it written right here. When you multiply radicals, you can split them up. You can split them apart. So we can write this as the square root of 16 multiplied by the square root of 6. So when I look and I say, the square root of 16, what number multiplied by itself equals 16? That's going to be 4. And we really can't break down 6 any further because the multiples of 6 are 1, 2, 3, and 6. 1 times 6 or 2 times 3. And none of those numbers are perfect square numbers, right? I don't see 2. I don't see anywhere on my perfect square list. I don't see a 1, 2, 3, or 6. So I really can't simplify this any further. So this is going to be my final answer. So we simplified the square root of 96 into 4 square root 6. Multiplying square roots. We kind of just talked about this, okay? Square root of 10 times the square root of 5. If it looks like this, and again, they are both square roots, we can put them underneath the same house, the same square root sign, the same radical sign, okay? So square root of 10 times 5 is 50. Now let's think. Are there any perfect square numbers that multiply to get 50? And there are, in fact. It is 25. So I'm going to think about this. I'm going to rewrite this as 25, the square root of 25, times the square root of 2. What number multiplied by itself equals 25? That's just 5. And I'm left with 5 square root 2. You can't simplify the square root of 2 any further. Last part of our review is dividing square roots. It's very similar to multiplying. Okay, again, when you have fractions, it means divide, and you want to try to simplify everything on top and everything on bottom first. So let's look at the square root of 8. So if I think about my factors of 8, I have 1 times 8, and I have 2 times 4. I see, hey, 4 is a perfect square number, so we're going to rewrite this as, on top, we're going to say the square root of 4 multiplied by the square root of 2. And then on the bottom, it's actually really easy to simplify. The square root of 100 is a whole number. It's just 10. So now, the only thing I have left to simplify is on top, square root 4 times the square root of 2. I know that the square root of 4 is 2, so I'm going to say 2 square root 2 all over 10. We're so close to being done, but we see that, hey, I've got a whole number of a 2 divided by 10. I know that I can factor out this 2. So I'm going to divide the top by 2, and I'm going to divide the bottom by 2. 2 divided by 2 cancels out. So I'm just left with the square root of 2, and 10 divided by 2 is 5. You got to always simplify it as far as you can. And the last step is we do not in math leave the radical sign in the denominator. So the question is that we have to think about is, how do I get rid of this square root sign in my denominator? And I want you to think about when we're talking about the opposite of exponents, again, like 3 squared equals 3 times 3, which equals 9. However, the square root of 9 equals 3. We said, hey, if I have 3 and I square it, but then I take the square root of it, it actually cancels out. And I'm left with just 3. So we're going to use that idea to move this radical sign from the denominator to the numerator, from the bottom to the top. So I'm going to multiply it by the square root of 3. And if I do something on the bottom, I also have to do it on the top to keep my equation balanced. Square root of 3 over square root of 3. You might say, you're changing the problem. Let's think about that. If I take 5 and I divide it by 5, it equals 1. If I take 2 and divide it by 2, it equals 1. So if I take the square root of 3 divided by the square root of 3, it still equals 1. So I'm multiplying this by a version of 1, and we know that multiplication times 1 equals itself. So that's called, we can do that. That's an identity in math, that if we multiply it by 1, we're still going to get the same answer. Square root of 3 over square root of 3 is a version of 1. And then, like we just talked about, square root 3 times square root 3, they undo each other, okay? They're canceling each other out. So all we're left with is a 3 on the bottom. 2 square root 3 over 3.